So hello everyone, welcome back to the channel, welcome back to the learning field. So this is the lecture 15 of our LPB series. Okay, so this is the lecture 15 of our LPB series for the GATE exam and CSIR NET exam and any other exams, higher math exams. Okay, so in the last session or in the last lecture we discussed what? We discussed the VAM method and VAM method with if there is no allocations in a particular cell. We discussed that topic. Okay, so in this topic we're starting the assignment problem. Okay, so assignment problem is also a very important chapter or important part of LPP. Okay, so let's start, and before starting I am requesting those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and subscribe the channel. Okay, so what is the assignment problem? Okay, suppose a company has n salesmen and n cities. Okay, should be assigned to which city? So suppose there is a company, the company has n salesmen and n cities in which the companies has to deliver or has to deliver the product, deliver its products. Okay, so should assign, that is the कंपनी का जो सिटीज है एन सिटीज है एन सेल्समैन है, मतलब कौन सी सिटी में कौन सा सेल्समैन को असाइन करेगा कंपनी, वो है ये इसका प्रॉब्लम. ओके, सो सच दैट द कंपनी गेट्स द मैक्सिमम प्रॉफिट बाय सेलिंग इट्स प्रोडक्ट्स. ओके, सो कंपनी कैसे जो है ये सेल्समैन को असाइन करे जैसे कि कंपनी का प्रॉफिट मैक्सिमम हो. ठीक है, इसका प्रॉफिट इसका प्रोडक्ट सेल करके. ठीक है, तो दिस इज द मेन थिंग in the assignment problem. Okay, such type of problem is known as assignment problem. Assignment problem is a special type of transposition problem where each supply is one and each demand is one. Okay, in each case the supplier will be assigned one destination only. Every destination will have one supplier only. Okay, so this is basically one correspondence between the supplier and the destination. Okay, in the transportation problem there are various destinations and various suppliers, but in the case of assignment problem there is a one connectivity between the destination and between the destination and supplier. Okay, so mathematical formulation देखते हैं इसका क्या होता है. So mathematical formulation, let there be n jobs and n person be available with the different key skills. Let Cij denote the cost denoting the jth work by ith person. Okay, then the कॉस्ट मैट्रिक्स इज गिवन बाई. सो दिस इज द कॉस्ट मैट्रिक्स. मतलब क्या है, यहाँ पे सपोज इन जॉब से एंड इन पर्सन से कौन सी जॉब को किस पर्सन को यहाँ पर असाइन किया जाए, जैसे कि कंपनी का जो प्रॉफिट मैक्सिमम हो वो है इसका प्रॉब्लम. ठीक है, तो मैक्सिमम दिस आर द पर्सन्स J1, J2 and Jn are the persons, and jobs are P1, P2 and Pn are the persons, and J1, J2, Jn are the n jobs. Okay, so this is the C11 cost, that is the cost if the P1 person assigned to J1. Okay, this is the cost C21 if P2 person assigned to the job J1. Okay, ऐसे करके यहाँ पर होता है. ठीक है, so this is the cost matrix you can say. Now the problem is to determine which job should be assigned to whom so that the total cost of completion of the work will be minimum. Okay, so consider the set of variations xij such that ij equal to 1 to n such that xij equal to 1 if ith person is assigned to jth work and 0 if ith person is not assigned to jth work. Okay, so this is the value of xij with a restriction summation j equal to 1 to n xij equal to 1 and summation for j equal to 1 to n, and summation j equal to 1 to n xij equal to 1 for I equal to 1 to n. Okay, now this is the mathematical formula of the assignment problem. You can just see it. Okay, maximize z equal to, in the transportation problem we are go for minimization of the optimization function. Okay, and in the case of assignment problem we go for the maximization of the assignment problem. Okay, so this is the difference between the assignment problem and the transportation problem. Okay, so maximize z equal to summation I equal to n, summation j equal to n, Cij xij subject to summation j equal to 1 to n xij equal to 1 for I equal to 1 to n, and summation j equal to 1 to n xij equal to 1 for j equal to 1 to n. Okay, here obviously xij's are greater equal to 0. Now there is a theorem, let us come to that theorem first. So the theorem says that if a constant is added every element of any row or column of the cost matrix Cij in the assignment problem of minimization, then the assignment which minimize the total cost for the new matrix will also minimize to the total cost for the original matrix. Okay, so this is the theorem. And the second theorem says that in an assignment problem of minimization with the cost matrix Cij, let Cij greater than 0, then a feasible solution Xij ij equal to 1 to n which satisfied z0 equal to summation I equal to 1 to n, summation j equal to 1 to n, xij equal to 0 is also for also an optimal solution. Okay, so these two are the important theorems related to the assignment problem. Okay, now the solution procedure, we comes to the solution procedure of the assignment problem. Okay, the solution method is known as the Hungarian method. Okay, reduce the cost matrix method. Okay, so the steps for the Hungarian methods are: step 1 is first row reduction. Okay, subtract the minimal element. So there is a matrix, suppose this is the square matrix. Okay, so in the case of assignment problem, the coefficient matrix must be what? The coefficient matrix must be square matrix. But in case of transportation problem, the coefficient matrix may or may not be the square matrix. Okay, so subtract the minimum element from each row from all the elements of the respective row in the matrix. Okay, column reduction. After completion of row reduction, subtract the minimum element of each column from the other elements of the respective column. Okay, step 2a, starting from the first row, the cost matrix received in step 1, examine the rows one by one until a row containing exactly 1 0 is found. Okay, so then an experimental assignment is indicated by the third bracket. Okay, is marked to the 0. Okay, now the cross all the zeros in the column with the assignment is made. That means what? That means if we suppose get there is a 0, then all the elements of the columns are not assigned. That means what? That means this person assigned to these jobs. Okay, so this is the assignment. Examine all the rows in this way. Okay, so इस तरीके से all row को check करना है. Then number B क्या है? When the set of all rows has been completely examined, an identical procedure is applied to successfully to the columns. Starting with column 1, examine all columns to find the columns containing exactly 1 0. Then make an experimental assignment in the person and cross all the other 0 in the row which is assigned as assignment was made. Okay, so that means same procedure follow करना है column में भी. ठीक है, then continue this successive operations on the row and columns until all zeros have either been assigned or crossed. That means ये process को apply करना है after what this is that the successive operations on the rows and columns until all the zeros have either been assigned or crossed out. Okay, then now there are two possibilities: all the zeros are assigned or crossed out, and at least 2 zeros are remained by assignment or by crossing out in each row or column. In this case, we try to exclude some of zeros by trial and error method. After completion of the step 2, two situations can arise. Okay, so the number of total assignment of zeros equal to n equal to order of the matrix, the assignment is the n optimal. Okay, and the number of total assignment assigned zeros is less than n, then we pass on the next steps. Okay, so if the all zeros are assigned, that is the number of zeros assigned are equal to the order of the matrix, then this is the optimal, and if it is less than, then this is not the optimal. So for that case we go to the next steps. Draw the minimum number of horizontal and vertical lines to cover all the zeros. Step 3. Step 4, select the smallest element from the uncovered element, then subtract the smallest element from all those uncovered elements, and add the smallest element to all those elements which are the intersection of two lines. Okay, that means suppose we are covered this line by those, and this is the vertical line. Therefore we subtract all the elements, the minimum element from all the elements of the matrix, and add these elements to these intersection points. Okay, this is the case. And step 5, Go to the step 2 and find the required assignment. If the assignment is not optimal, then repeat step 3 and step 4 alternatively until we get the alternative assignment. Okay, so this is the process to solve the assignment problem. Okay, I'll share the PDF in the Telegram group, so you can read it. I think these steps are very easy to understand. Okay, so this language of this book is also very easy to understand clearly. Okay, now to draw the minimum number of horizontal and vertical lines to cover all the zeros, methods क्या है? So starting from the first row, examine all the zeros are successively which contain exactly one zero. Draw a vertical line along the column containing that zero. Proceed in this way until the rows have been examined. Okay, repeat this process for the columns and reduced matrix of the reduced matrix. Okay, so this is the case. If there is no single zero of any of the rows and column matrix, then arbitrarily choose a row और कलम. सो देखो यहाँ पे जो जितना केस हो सकता है सभी के सभी डिस्कस किया है, ठीक है. ऑफ द जीरो, फर्दर सिलेक्ट द आर्बिट्रारीली एनी वन जीरो इन दैट रो. द कॉलम इज thus chosen and draw vertical horizontal line along the vertical or horizontal line along the column or row containing that zero. ये जो है फर्स्ट मेथड है एंड सेकेंड मेथड का है. चूज दैट रो or column which contains maximum number of zeros. This is the method we mostly used. Okay, cross that zeros row or column by the dotted horizontal or vertical lines. If more than one row or column contains maximum number of zeros, then choose any one of them arbitrarily. Then repeat the same process on the matrix with uncrossed and rows and columns. Okay, and with uncrossed rows and columns. This will give the minimum number of lines to cover all the zeros. Okay, so these are the process to getting all the process. Okay, so I request that you should read once to the complete process of Hungarian method. Okay, so let us take an example first. There are 5 machines and 5 jobs to be assigned and associated cost matrix is as follows. Okay, find the proper assignment. Okay, तो देखो यहाँ पर चारों के चारों मशीन है. दीज आर द 4 मशीन्स 1 2 3 and 4 and 5 मशीन्स एंड जॉब्स भी 5 जॉब्स है A B C D E. ओके, तो कौन सी मशीन को कौन सा जॉब असाइन करा जाए, ये है इसका प्रॉब्लम. ठीक है, तो देखो सॉल्यूशन वी सब्ट्रैक्ट द मिनिमम एलिमेंट फ्रॉम द फर्स्ट from each row from the element. Okay, so here 3 is the minimum element, so we subtract 3 from each element of the first row. Here 1 is the minimum element, so we subtract 1 from the second row, and here 7 is the minimum element. Here I think 12 is the minimum element, and here 5 is the minimum element. Therefore we subtract these elements from each element of the corresponding rows. Okay, so these will get the matrix after subtract the minimum elements from each row. Okay, so this gives this matrix. So 3 9 0 8 and 12. Okay, these types of matrix. Now we then apply the similar methods for the columns. Okay, so here for the first column, okay, so there are no zeros and the minimum element is 1. Therefore we subtract 1 from each element of the first column and the remaining. Okay, and here is also 0, therefore this is same column, and here we get also zeros, here we get also zeros. Here in this column 4 is the minimum element, I think, yes, and we subtract 4 from each element of the fifth column. Okay, so we get, after the subtraction we get this matrix. Okay, now each column excepting first and fifth column has a 0. This the writing is corresponding the table 2. Then subtract the minimum element of the first and third column from all the elements of the respective column. यहाँ पर लिखा है, ठीक है. Now we find the zeros. If there are 1 0 in a single column, sorry, single row first. So from table C, what is saying here? It is seen that all the zeros are either assigned or crossed out. That means we first assigned how? So first we see the first row. Since in the first row there are only 1 0. Therefore we choose this 0 and the zeros corresponding to this column will be crossed out. Okay, okay, so this is the process. Now we go to the second row. We see there is a 1 0 in a single and we write it on the third bracket and we crossed out the corresponding zeros of the corresponding columns, that is in the fourth columns. Okay, then this process is applying throughout the matrix. Okay, therefore we get the zeros here, this 0, this 0, this 0 and this 0. Okay, so we get 4 zeros. So see, we get 4 zeros. Now we try to cover these zeros by horizontal and vertical lines. Okay, by minimum number of lines. Okay, so see here we covered these zeros by 1, this 1, 2, 3 and 4. So 4 lines, but the order of the matrix is 5. Therefore this is not the optimal solution. You can cover these zeros by any types of lines. You can say this is not only the one choice. Okay, this is just one choice. You can choose another choice also. Okay, so suppose if we draw the 4 vertical lines, so this is also the one choice, you can say. Okay, so their number of lines is also 4. Therefore this is less than the order of the matrix. Therefore this is not the optimal solution. Okay, so since the minimum number of horizontal and vertical lines is 4, that is cover all the zeros, is less than order of the matrix, so optimal assignment cannot be made. So this is not the optimal solution. Okay, here the smallest uncovered element is 2. Okay, so this is the next process. This 2 is the minimum element from all the uncovered elements. Okay, therefore we subtract 2 from all the uncovered elements and add it to those elements which are the junction of 2 lines. So this means we add here and add here, and all the remaining elements 2 will be subtracted. Okay, so we then get the modified matrix in the table 5. Okay, and draw again the minimum number of horizontal and vertical lines. So see, from this matrix, so this is 2 subtract, that is 0, 7, 0, 6 and 6. Okay, so this is the matrix. Okay, in all the zeros in table 4, the minimum number of line is 5. The minimum number is 5, in which all the order of the matrix 2 equal to order of the matrix. So minimum number is number of line. Okay, so see, these are the zeros after subtracting 2. So this is a 0, this is a 0, this 0, all we get many zeros. Okay, so see, here we now try to cover the zeros by minimum number of horizontal or vertical lines. Okay, so see, this is a process 1, 2, 3, 4 and 5. So we covered all the zeros by 5, minimum number of 5 lines. Therefore optimal solution is satisfied. Okay, so optimality condition, we reach the optimality condition. Okay, now we draw a table and write only the zeros. Okay, so these are the zeros, 0, 0 and 0, 0, 0, 0, 0 and 0. So we write these zeros. Now we first see the rows in which the row contains a single 0. So see, in the second row, this row contains a single 0. Okay, so we choose this 0 and cross out the corresponding zeros in the corresponding columns. Okay, so we crossed out this 0. Now in the fourth column there is a single 0, therefore we choose this 0 and crossed out the zeros corresponding to that column. Okay, so we crossed out this 0, and then in E there is 1 0 only in the row, therefore we choose this 0 in the row and there is no zeros in the corresponding column. Okay, so this is the selection and this was already crossed out, therefore we choose this 0 and here only 1 0 is. If we choose this 0, then this 0 is crossed out, since this 0 is corresponding to this column, therefore this is crossed out and this is the 0 lastly remaining. Okay, so I just see it once again, see carefully. Okay, just see it once. The zeros are this 0, this 0, this 0, this 0, this one and this one. So see, this is a single 0, therefore we choose this one and cross this one, this is the corresponding column. Then we choose this 0, there is no 0, there is a 0 corresponding to this column, therefore this is crossed out. There is a single 0, therefore we choose this one. And then after that, this first row contains 1 0, therefore we choose this because this is already crossed out, so this is now crossed out and this one single is remaining, so this one is selected. Okay, so in this way we choose the zeros. Okay, after crossing out the zeros, we see the first row contains only one uncrossed 0, so this is the process here, just write it here. Okay, so then we get 5 assignment as the required by problem. Okay, so that means the assignment A goes to 1. Okay, so this is the assignment. A goes to 1, B goes to 4, C goes to 5, D goes to 3, and E goes to 2. Okay, so this is the optimal assignment. From the cost matrix, the minimum cost is corresponding to that element. Okay, so this cell you can say. So the minimum cost is, you go to the next problem, this one 6. Okay, so 6 plus 1 plus 11 plus 12 plus 5, this is equal to 35 units. That means the elements, that is the cells, these cells, the cost of this cell, these 5 cells are the optimal solution. Okay, so the optimal cost, that is the minimum cost, this unit 35 units. Okay, so this is the content for this video. If the content is helpful, then please give a like to this video, share with your friends, and subscribe to the channel. Okay, see you again in the next video. Okay, thank you.